This is lesson 5.6. These are the final two methods for proving that triangles are congruent, and they're the ones that are more angle dominant. So we have angle, side, angle, and angle, angle, side. So both of them have the same information, but here, when I have my two angles, I'm able to connect them to each other by the side that was marked congruent, so ASA, whereas here, if I connected the two angles together, it's not the side that was congruent. So this would be AAS. All right, so that is the difference between them. For these, I do find it is especially helpful to mark our things until we're really comfortable with this method. So also remember, the things that we know we're allowed to mark as congruent are our reflexive or shared sides, our vertical angles, and also our alternate interior angles, and our corresponding angles. So in example 1, let's determine if the triangles are congruent, and if so, finish the congruent statement and explain our reasoning. So we do have a lot of parallel lines here. So angle 1 and angle 2 would be congruent by alternate interior. The same with angle 4 and angle 3. And we have a reflexive or shared side. So now that puts me at two angles and the side between them. So this would be ASA. And it's a lot easier to write the congruent statements for these because so many angles are marked for us, it's easier to see which ones match up together. So if I started with ABD, I started with double, nothing, single, right? That's how I marked it, double, no marking, single. So in the other triangle, double, no marking, single would be DCA. In B, the only extra thing I can mark is my reflexive side. And now I have an angle here, and this is my side. Connecting my angles together does not form that side, so this would be AAS. And in this triangle TRU, I went single mark, double mark, none. So in the other triangle, single, double, none would be SUR. So here's try 1. Pause if you would like to try it. The answers are posted online. Example 2, what additional information is needed to prove the triangles are congruent using the given method? So if I want to use ASA, let's mark our reflexive side first. If I have an angle and I have a side and my goal is for S to be between the two A's, so I do want the connection to be that side, that puts my other angle over here. I can't call it angle A because there's more than one angle A in the picture, so we're going to go to 3 letters. We'll call it angle CAB. Let's try to write that A, B, and angle IAB. For part B, we also have the reflexive side we can mark. We have an A and we have an S, and I want AAS this time. So I don't want this side to be between the angles. So I would not use the other end of this side. I'm going to go ahead and put my other angle here at W and at Q. Okay. Here is a try problem for you. Pause if you'd like. Answers are posted online. And now on to our proofs. This one gives us a whole heck of a lot of information, but we kept it all into step 1. We did see the word midpoint in our given statement. M is the midpoint of DF. So now that we're making DM and FM congruent, that would be the definition of midpoint. And we already have enough information in our picture to say that the triangles are congruent. I have two angles and the side not between them. So my method will be AAS. This is a try for you. Pause if you would like to give it a shot. The answers are posted online. Our last example, we have everything that was given to us in the first line, but nothing is marked, so R is congruent to D, and they didn't mark it for us this time, so we make sure to mark that. And the other given was that L is the midpoint of WE. So we know by seeing a word, we could use the definition of that word. And if I'm cutting WE in half, WE is right here, that would make these two the segments that are congruent. So we're going to say segment WL is congruent to segment EL. So looking at my picture, because I can't do anything else with the information I've used in my proof, I also have a pair of vertical angles. So I'm going to mark those, and I'm going to say it in my proof. And remember, we can't call it angle L because there's too many angles at vertex L. So angle RLW is congruent to angle DLE. And that was the vertical angle theorem. So it actually looks like we have enough information to prove that the triangles are congruent. I have two angles and the side not between them, so I can use AAS to prove that the triangles are congruent. Let's say RLW, 1, 2, none. And now 1, 2, none is DLE. And we know immediately following one of the ways that we're proving triangles are congruent, we would use CPCTC, corresponding parts of congruent triangles are congruent. And if I'm trying to ultimately prove that L is the midpoint of RD, then I need to say that RL and DL were the matching pieces. And RL and DL do in fact correspond in my congruent statement. So RL is congruent to DL. And I can now say that L is the midpoint of RD by definition of midpoint. And that's our proof. So the last proof is for you to try. Pause now if you'd like, or try it when you're done. Answers are posted online. But that is the end of section 5.6.